in this unit, we're going to talk about bivariate data, which means we have two variables now instead of one. So for the most part, we're only going to look for relationships between two things. So we will have explanatory and response variables about 90% of the time. So if you're looking at a situation and trying to determine explanatory versus response, you're looking for what you're measuring. So the response is what you measure from unit 1. And the explanatory is what's explaining what's happening. So if we're talking about apples, the weight is going to be what you measure, so that's your response. The circumference is explaining, so that's your explanatory. For gasoline, the gallons remaining in your tank is what you're going to measure. The number of miles you drove since filling up is going to explain how much gas is left in your tank. For scuba diving, visibility is what you would measure, and it's going to be explained by the depth that you are. Climbing a mountain, altitude and temperature. Temperature is something you are going to measure, and it's going to be explained by your change in altitude. Grip strength and age. So typically your age is going to explain your grip strength. So you measure grip strength, you explain age. For drivers, blood alcohol level and reaction time. The reaction time is something you're going to measure, that's a response, and blood alcohol is what is going to explain it. All right, so you know response and explanatory variable, we talked about it in the last unit, you just have to be careful not to use independent and dependent variables. So part of your job in your discussion post or your discussion write-up is you're going to look at both of these examples and decide what the explanatory and the response variables are for example 1 and 2. So within this unit, we're going to create scatter plots now and look for relationships. And so when we create a scatter plot, typically we're going to put our explanatory variable on the horizontal axis and the response variable on the vertical axis. So we have this particular example that is just mean SAT math scores, which is our response. And we think it's a response to the percent taking the SAT. The other thing you need to notice when we look at these scatter plots is notice that it doesn't start at 0, 0. It starts at 450 on the vertical axis, and that's perfectly okay. You can kind of zoom in and you don't even need to show really that scale. All right, so this just goes through the steps of how you would go about graphing this. It's just like graphing points. We're taking an X and a Y point, graphing it on an XY coordinate plane. So first you have to decide which variable is going to go on each axis, which means you have to decide if you have an explanatory and a response. You're going to label and scale. So remember, we talked about it before, you lose points. You do not label your axes, so make sure you label everything. And then you would plot all of the individual data values. All right, so your job as part of your discussion is to take this scatter plot, this data, decide which is our explanatory and which is our response, graph it on this, and that will be part of what you turn in. All right, when we describe a scatter plot, in quantitative data we did stocks. Here we're going to do direction, form, strength, and then our outliers or clusters, which is like our unusual feature part of it. We talk about direction, really that has to do with the slope. So we're looking for the relationship. Are they both going in the same direction? Do they have a positive relationship? Or do they have a negative relationship? And make sure also you include context. For form, you're really just looking to see, do I have something that looks like a curve? Is it a line? Is it a parabola? What's going on with my data set? For strength, you're just looking for, based on the form you think it is, how closely do the points line up and follow that form? And then the last one's kind of self-explanatory. We have things that don't follow the rest of the data set. Do we have clusters of data? Is there anything unusual going on? And throughout all of this, context, context, context. Here's the example from before, the percent taking SAT and the mean math scores. And we go through and talk about direction, form, and strength. And they give you an example of what it should look like. So for direction, it talks about the pattern moving from upper left to lower right. Ultimately, it's a negative association, which you could kind of associate as heading downward, so it's like a negative slope, but they also tie in the context piece. For form, we see a little bit of a curve in the data. So it looks a little bit like exponential or something along those lines. And so that's what we're talking about here. And we also have our context in there. For strength, you see most of these line up. We really can see that curve pretty well, but it's not perfectly lined to our curve that I drew in. So we're going to say it's moderately strong. And then again, context piece. Then we have a couple that stand out, West Virginia and Maine, which you can see on the graph are these that are away from that curve. All right, so just to recap, a positive association, basically you have both variables. When one increases, the other also increases. Or if you think of it as one decreases, the other decreases, that would be a positive association. For a negative, they have to be going in opposite directions. As one variable increases, the other decreases, and vice versa. So this is just talking about how you decide what the association is. So your job is to answer the questions from before, explanatory response, graph it, and make a quick summary in a paragraph about what you found from this